Alright, for this screencast, we're going to review one concept, the idea of mechanical advantage, which you covered quite a bit for the first quiz. And the second concept, we're going to spend most of our time on this one, is levers and all the calculations and the types of levers that we talked about in class. But just as a quick review, mechanical advantage is the amount by which a machine can multiply an input force. Okay? And if you remember, the formula we used was F out over F in, and this kind of described, okay, if I have a certain amount of force that I'm putting in, how much will I get out? And if I get out more than what I put in, well, that's going to be a pretty good circumstance. That means that my mechanical advantage is going to be greater than 1, and that puts me in a pretty happy situation because I get out more than what I put in. And if you also remember, if the mechanical advantage is less than 1, what that means is I get out less than what I put in. And in a lot of circumstances, I'm not as happy with that situation. All right? But let's go on to levers. And actually, I want to refer your attention to a chart that we'll be creating down here. Okay, so there's actually 3 types of levers. Going to first class, second class, and third class. Now this doesn't mean that first class levers are the best, okay, and third class levers are the worst. It's just a way of describing it. It doesn't mean one is better or worse. Alright, so first let me just draw them here. And there's a few different ways that we can categorize levers. What I want you to notice with first class levers, the fulcrum, or the point that tips on the lever, is somewhere in the middle. It doesn't have to be exactly in the middle. It could be closer to here or closer to there. The only key point is it's not right on one edge or the other. Okay. For second and third class levers, the fulcrum is actually on one end. I've drawn it on this end, but it could also very well be on the other end. Okay, so let me label this. This is the fulcrum. It's a part on a lever that essentially tips. Okay. Now, in terms of locations, I also mentioned that as well. The second way we can actually discuss or show fulcrums, levers, is through the relationship between the input and the output force. Okay? So if you actually want to refer to your textbook, they also give you quite a good amount of information on this as well. And if you're doing that, so let me just get some red here. This information is found on page, let me see, 132 to 135. Okay, you can definitely use these pages to help you to study for it. Okay, now going back to first, second, and third class levers. Now, another way you can describe it is the F in and the F out are on opposite ends of the lever for first class levers. For second class levers, the input force and the output force are actually right next to each other. Okay? And the output force is actually more in the middle here. And when you get to the third class levers, the relationship here is the input force is actually in the middle, and the output force is actually on one end. Okay. So if I actually want to draw those fulcrums in, one of the fulcrums in the middle here, it's on either end right here. Okay. So one way of classifying, let's use green, is by fulcrum location. So I can kind of compare where the fulcrum is, as I did in this first column. The second way I can also compare them is relationship. It's going to be short form relationship between the input force and the output force. So what I did up here, so this is on either end. For this one, the output force is in the middle. For third class levers, the input force is in the middle. The third relationship is direction of the input force of the output force. and that's what I started showing up here. So for first class levers, the direction difference is the input force is going, let's say, down. The output force would be going in the other direction. Okay. For a second class lever, the input force and the output force both go in the same direction. And for third class levers, the output force and the input force also go in the same direction. Okay, so those are a few different ways. Those three down here are three different ways you can compare first, second, and third class levers. Okay. Now, in terms of examples here, your textbook gives you really good examples of these and much better diagrams than I can show. But if you want to refer to some different examples, you can look at, for this one, look at page 132, and it's lifting a paint can lid. Okay. And that's using a first class lever. If you want to look at a second class lever, just refer to the top of page 133, and that is a bottle opener. And finally, we also went through this one in class. If you also look at page 133, you can look at raking these as another example of a third class lever. Okay? So these are first, second, and third class levers. What I'm going to do is I'm going to go through two quick examples of what they are. So I'm going to clear this page and let's continue with it. Now, the one very important formula you need for this one is IMA equals to the length of the input arm over length of the output arm. Put this in a box here. And let's get these examples going. So let's say here, for the first situation, you are lifting this rock here, okay, and you are pushing down on it really hard. So your input force would be going down. If you have any experience with this, or you kind of can imagine what's going on, the output force will be going in that direction. Okay. Now, it's very important to know what kind of lever this is, and this one is a first class lever. And we can know that based on three pieces of information. The first one is the location of the fulcrum, right, in between the input and output forces. The second one, I'll just put this 2 up here, is the location of the input and output forces, so they're on opposite ends. Okay? And the third way we can compare them is also the direction. So the input force is going one way, the output force is going the other way. So therefore, this is a first class lever. Now let me add some measurements. Let's say this here is 1.2 meters, a little bigger. Let's say from here to here, 1.8 meters. So to calculate the IMA, it's equal to the length of the input arm to the length of the output arm. How do we know what the length is? Well, the length of the input arm, let's use blue here, that's going to be here. And that's actually the gap between the fulcrum and the input force. So that's going to be 1.2 meters. The outputs is the other one. The output arm is the distance between the fulcrum and the output force, which is 0.8. And let me get my calculator out here. Do 1.2 divided by 0.8. I end up with 1.5. And that is my IMA. And again, there's no units for it. Let me show you one more example here. So let's say, let me draw this properly here. Let's say you've got this kind of wheelbarrow, you're lifting a mound of dirt, and you are up here, and you're lifting it up. So the input force is where you're lifting it up. What's the output? Let's assume the output is right here, the center of this kind of mass. And so, and add some dimensions. Let's say from U to the output force is 0.6 meters. And let's say from U to the wheel would be, let's say, 1.1 meters. Okay? So, again, we want to calculate, actually, let's figure out the class of the lever. So, what is happening here? If I want to draw up here, what's going on here? The fulcrum is actually over here, because it's the wheel that tips up. The output force, what's being lifted is the dirt. It's in the middle. The input force is what you are putting in. So, based on this, if you refer back to the diagrams from before, this is actually a second class lever. And again, you can compare based on let me just circle it, the fulcrum location, what's in the middle, so the output force is in the middle, as well as the direction. The output and input forces are in the exact same direction. Okay? Now let's calculate the IMA. So IMA is equal length of the input arm over length of the output arm. So what is the length of the input arm? Well, that's from where you are all the way to the fulcrum. So that's actually 0.6 plus 1.1, because you have to go all the way to the fulcrum. The output arm is the distance from the fulcrum to the output force, where that's located. So that's simply 1.1. So when I simplify this, I have 1.7 divided by 1.1. And again, taking out my calculator, I have 0.7 divided by 1.1. I end up with, let's just round to 1.5. Will be my mechanical advantage. And there you have it, 2 examples of IMA using first, second, and third class levers.